So we're going to solve some trigonometric equations. Our first example is cosine of u equals -1/2. We're looking for solutions in 0 to pi. So what we're looking for then is a value that we can plug in for u that makes this cosine u equals -1/2 a true statement. And our u is going to be in this range. Okay, so remember that cosine u is the x-coordinate of a point on the unit circle that corresponds to u. I'm going to actually draw that here. So for instance, this angle here is u, and the x-coordinate of this point is then cosine u, and the y-coordinate is sine u. That's less important right now. First, let's find the points on the unit circle that have x-coordinates -1/2. So effectively, we're trying to solve this system of equations. And I don't really actually want to solve this so much as I want to just get a picture of what's going on. So the first equation is just this line. That's the x-coordinate has got to be -1/2. And then there's the unit circle, which is drawn here. And we are interested in the points of intersection. Each of these points is going to be associated with a solution, or even infinitely many solutions to this equation. Only one solution when we restrict our solutions to this set, as we'll see. Okay, so each of these points corresponds to a terminal side of an angle. So the initial side is along the x-axis, and the terminal side is the one that intersects the circle at those points. So there's one option, and I have indicated the angle that will be our solution in red. We find that by starting from the initial side and moving until we hit the terminal side. So that way we're starting from the angle 0 and moving toward 2 pi. And we'll stop when we hit that terminal side. So that's one angle that we need to find. And the other angle is we start with the initial side and we move until we hit this terminal side associated with the other point. So the other angle we're looking for is the purple angle. There are no more solutions if I continue around and I do not stop at this terminal side or that terminal side. I find nothing else. So there are only two solutions this equation if we're restricting ourselves to this interval. Okay, how do we find these red and purple angles? The first thing I'm going to do to understand this is to draw this part of the picture down below here. So I've just copied that, and I haven't drawn the unit circle again because I don't want to clutter the picture. So what's true about it is that we have a hypotenuse of 1, and this, let me call it assigned length, is -1/2, because the x-coordinate of this point is -1/2. So I recognize that triangle if I multiply everything by 2 as a 30, 60, 90 triangle. So that angle is 60 degrees, the red angle, which is pi/3. So that gives me what I'm calling my reference angle. That's a reference angle. This is a reference triangle. So how do I find the red angle then? I can go 2 pi, and then I can back up pi over 3 to land at my terminal side. So that means my angle is pi minus pi over 3, which is 2 pi over 3. Alternatively, you could think of this in degrees. So the reference angle is 60 degrees. We go 180 degrees, and then we'll back up those 60 degrees to land at our terminal side, which is 120 degrees then. For the purple one, the reference angle is exactly the same. It's pi over 3. So the angle we find is pi plus the pi over 3. That's how we land at that terminal angle. So pi plus pi over 3 is 4 pi over 3. Or if you want to do this in degrees, it's 180 degrees plus 60 degrees is 240 degrees. There are therefore two solutions, the red one and the purple one, and the interval 0 to pi. There are an infinite number of solutions to this equation if we don't restrict ourselves to that interval, because there are an infinite number of angles that have the same terminal side. Okay, let's look at an example where we're dealing with a tangent. Let's solve tangent of u equals -1 for u in this interval 0 to pi. This tangent is a ratio, so I don't know what the coordinates are, but I do know that the ratio is -1. So I have two choices. I can either go to the right a and down -a, so the ratio is -1, or I can go to the left -a and up a to find my point on the unit circle, and the ratio is also -1. These are both isosceles triangles, so we see that that angle is 45 degrees, or pi over 4. So how do we find these angles? What are they? Well, we form the terminal sides. There they are. And for the first angle, it's as we start off from the initial side of our angle on the x-axis, we proceed around until we hit that terminal side. And that is the same as going beyond that all the way to 180 degrees, and then we back up the 45 degrees, or in radians, we go to pi, and then we back up pi over 4. Getting a common denominator, we see that that's 3 pi over 4. For this terminal side, we start off at our initial side and we proceed around in the positive counterclockwise direction until we hit this. Now we could also proceed all the way to 2 pi and then back up. I've drawn that down here. Pi over 4 to arrive at our terminal side. So we end up with the solution of the angle being 7 pi over 4. So the solutions are 3 pi over 4 and 7 pi over 4. And like the other example, there are actually an infinite number of solutions if we remove this restriction. But with this restriction, we're only allowed to go around once looking for terminal sides. So this is it. Okay, next let's solve this. This is something that will not lead us to a special triangle, but the process is similar. We're solving this equation. This means that the y-coordinate of the point on the unit circle associated with u is 3/5. That's positive. So we're solving a system of equations where this is the line and the unit circle. So we're looking for the intersection. Those are those 2 points. So there are going to be two solutions to this. Let's look for the associated terminal sides. There they are. and the two angles associated with them. So I have colored one in red and one in purple just as before. There's a reference triangle. What is the reference angle? Well, we can just use our calculator to find out what u is. How do we do that? We use the arc sine of 3/5. That gives us an answer with our calculator. In degrees, it's 36.87. In radians, it's 0.6435. It's convenient sometimes to write the radian so it's some number times pi, so to that end I could also divide and multiply by pi, and that is the same as this. So that's about 1/5 pi. So if I divide pi up into 5 pieces, it's about one of those. And how do I find the red angle? Well, that is exactly the reference angle in this case because our point is in the first quadrant. But what about the purple one? The reference angle is the same, but how do we find the actual angle, which is this? Well, we can go all the way to pi and then subtract the 0.2048 pi, and that gives us 0.7952 pi. Or if you want, we can go pi and subtract the 0.6435 radians, and that'll give us 2.498. And there's an approximate answer to what our angle should be. So again, there are two solutions, and they are approximately 0.6453 and 2.498, or equivalently to, or maybe not quite equivalent, but almost, 0.2048 pi and 0.7952 pi. I'm going to just make a remark here. In these problems where you need your calculator, the calculator is only going to give you one of the answers. And it may not even be in the interval you're looking for. For instance, arc sine will give you an answer in negative pi over 2 to pi over 2. You're going to have to use that information to actually find the answers you're looking for. Arc cosine will give you an answer in 0 pi. Arc tan will give you an answer in negative pi over 2 to pi over 2. But these are only one solutions, and they may not be the ones you're looking for, depending on what the question is. So you must obtain other solutions, or all of your solutions in some cases, by hand, using the information that the calculator provides.